Hello, gentle readers. It's February 21st, 2024. Today, in Moments in Motion, continuing on the same theme, is still more consideration of meters per second or seconds per meter. 0 meters per second is infinity seconds per meter. There's usual idea of the continuous and the smooth and the classical and the whole of rest. The whole idea of relativity includes that anything is in its own particular frame, its rest frame, the frame of its rest. At the same time, when you think of something like Max Born and the restless universe, nothing's ever fundamentally at rest. Quantity would be infinity. But then how does it still yet go over? How can it ever cross if it's continuous? It would be kind of like the same kind of dichotomy. We would say, well, everything's finite particles since electron physics and ultraviolet catastrophe, the great success of spectroscopy, and how we're able to get things together with the photovoltaic, the optoelectronic, those being equating quantities, finite, whole numbers of electrons and photons. Vis-a-vis the idea is like, well, it can never actually be rational numbers because their inverse would be, as if it were 0, would be infinite. So you hear a lot sometimes, if you start to think about it and get into it, study physics and philosophy, what is infinity in physics, if it has one in mathematics at all first, and then how is it that many or most of the great successful results in physics were finding a way to resolve this singularities. It was for singularity theory and multiplicity theory. So here a lot of that has been studied with regards to the asymptotes, but also for functions, mappings, relations, and these sorts of things which affect that there is 0, 1, infinity, that these are the first numbers, 0, 1, and infinity, reciprocal of 0 and infinity, and 1 about it. These are the ends that meet in the middle. Somehow as they frame our classical milieu, what arrives at 1, or a whole, monism, in the middle of nowhere. So the idea of Born's restless universe, which is why, well, when nothing ever rests at 0, but it still had to cross to the other side. And so it would be much more jarring in juxtaposition to have it be jumping thusly. There are no jumps in the continuous, it's gapless. So trying to figure out exactly in as regards these notions, as that there really is a place deductively for infinity in physics, and the least amount, really. The idea is if there's got to be an infinity in physics, can at least just kind of be the simplest one, or is there a way to get it so that it won't leave itself into vagaries of its derived quantities with regards to the development? That here, that's been framed in a lot of these different readings about the nonlinear rank lowering and such, about the small angle approximation or linearizations, about singular points and the meromorphic, or analysis about that, about differential geometry as well. A lot of the ideas get into removing such notions of the multiplicities of singularities, working in a simpler sort of setting, and then being able to derive some results fantastically A new result not previously offered was available for its inputs, for its domain of applicability, which is thus restricted. The more general and the less general results that in some senses of the sensibility, fungibility, and tractability, that the less general and more specific has a reduced domain of applicability, and it has some more results in its thus more limited domain of applicability. So a lot of people find that as a source of opportunity with regards to then that being a way to say, well, something's been discovered, something's been disclosed, something's been found in mathematics. It gives a new result. Yet over time, as that has really been the way of things, it really has just left the other side of the field, the fruitful field, the fallow field, the sides, where fruitful means productive and fallow means unproductive. That the far fallow field is not necessarily unproductive. And it's possible to, and especially this so, that something like the methods of symmetry open up entire swaths of these fields. When we talk about topology and the toposes and bringing in the sheaves, that's a metaphor. It really relates to the idea, the fact that this tractability, so arrived at, is having that this area of the theory, the inner outer products, the spaces, the relations, the world of these things, the domain of the discourse, the universe of these things, has that if there's determine exactly and how to make one standard infinity and have one standard sort, for example, the line reals, the iota values, other such notions of the continuous domains that mathematics needs for physics, as discussed here. The ideas of what is the least amount of machinery that still is logically consistent overall and doesn't allow via principle of explosion that the nonsense arises from it. Gets into a lot of these different approaches and how things are. And in this manner, then, for moment and motion in meters per second and seconds per meter, in acceleration and deceleration and acceleration and growing and slowing acceleration and deceleration and growing and slowing deceleration, the accelerated and the retarded, that which gets into the notions here of the tendencies and propensities of oscillation and restitution, and as of attenuation for dissipation. These complementary quantities help to relay that, for otherwise these only two laws, motion and motion, rest at rest, motion and motion, rest at rest, equal and opposite reactions. That it relays the entire notion of the exchange. And it makes it so that besides the classical impulse, there's always the entire rotational milieu. These are things that get involved, and especially when, by the plain application of this logic of infinity, infinitary reasoning, that it arrives at effects, the doubling space, the doubling measure, the halving space, the halving measure. These line reals to the field reals, these signal reals to the field reals. It's very involved. And then as with regards to atomism, the Democritan, physics, chemistries, atomic chemistries, and angstroms and the Planck length, the 5 or 6 orders of magnitude above and below that scale, which is about 25 orders of decimal magnitude beneath our scale. Then we have the whole idea of superstring theory is like, that's twice that. fine enough a grain to be smooth, the rough and smooth plane. Euclid's and Poincaré's rough and smooth. The continuous, the reticulous. From what was quantized, discrete, elementary, to continuous, surface, flux. There's a lot going on that basically is for electron physics. These days it's electron neutrinos. The ultimately smaller particles going the other way. So that anything that flows has this flux as always a complement. What flows away fluxes back and through. This is the kind of way to make it so then that for particle physics, the conceit that at the atomic level things are atoms, or even discretely that objects are objects, though pretty much that does form the bodies and the systems that frames as composed of their atomically elementarily constituents, the statistical ensemble of same and scattering and tunneling theory of quantum dynamics, quantum electrodynamics, quantum chromodynamics. About the resonance theory and the molecular, just right above that. And about the Trans-Planckian and quark physics and such, right on down from that. That for the electron physics, from the ultraviolet catastrophe, is the idea then that here it's kind of called electron neutrino physics as for an infrared catastrophe, that together this second sort of catastrophe going from the atomic to the subatomic, from what ends its applicability as a theory of discrete particles back to a continuum mechanics that then meters per second and seconds per meter as well relate these same kind of notions where everything is classical in these interactions of these particles. Except with regards to like the path integral and the effects themselves, mass energy equivalency and the sum of histories. That even in the classical milieu, the effects of rest exchange momentum start adding right up. They add up a lot. So these are things that I wonder about when trying to figure out why it's meters per second instead of seconds per meter. That's meters per second is clear. In a locale or a milieu, everything is pretty much in the same milieu. You say there's no absolute motion, but it is locally, kind of. It's just not totally the field theory. It's not so often that something passes through, like a comet through the sky, or what, that would affect its own motion. But it is so. It's not so dissimilar that from a height, the potential is greater. That there really is the matter of that kind of thing. It's that potential. That here the fields of potential are the real fields. These are the classical fields, which are real fields insofar as that they just result as well themselves fields of potential. It becomes symmetric. As of about that same sort relation overall, the constituency of all matter and energy and space-time. Now that sounds rather grandiose. That's ambitious. But as well, it besides the fact that it's not really tractable to establish how all that is for all the sum of all histories and the sum of all potentials, at the same time, it's kind of easy to arrive at that's how it is because it's uncontradictory to itself. Nothing otherwise really adds up. Gravity cannot be perpetually doing work for no input. It's got to fall in somehow. So, these are the kinds of things that help then explain why when we were looking to meters per second or seconds per meter, classical motion, then how to relate that pretty much most directly to linear motion or rotational motion, the kinetic or kinematic here. And then with regards to the idea is being that the infrared is that on the corner of the second law of thermodynamics, heat is kinetic. But it's kinetic at the level of the atoms themselves is the idea of the model. Kind of like this, if the strong nuclear force is holding the nucleus together and the fall gravity falls in for it, then the heat is like the atoms are jostling together and they fall out this way. This is least action. What goes up must come down. Well, as well as an organization, you know what would maintain a system that by any mathematical model holds itself together. And here that there's notions of, in the molecular, that kinetic and charge is such complementary quantities. And then for light speed in the proton lifetime, you know, that this mass basically will live on out in the age of the universe while light's flux is coming in. That is basically this central notion of the flow of mass and flux out. This tetrad of quantities then sort of resulting. It's trying to keep things as simple as they can be while still having it so that the entire ornate detail is emergent from it. So these are the kinds of things that are being considered here. How to make it so for the mathematical fundamentals that it's like so. Because mathematical models automatically equip the physical models. And so what necessarily needs to go into the physical models to elevate them from classical to superclassical is the idea. That is the point. How to consider the absolute, how to consider the total. Here for the point, that being the mathematical point, the individual or geometries, the geometric, the local, the near field, the global, the far field, and the total, the entire gradient of the universe. The idea for them, these supermodels, pretty much of flow models and pressure models, and then overpressure and the superfluid, that which flows, has that there's a lot going on, and with not so much. Helping to explore that today we've really got it well put together with this statistical ensemble. Energy is the quantity and principle of least action, and then we just kind of call that thermosecond law. If you don't really think about nuclear transmutation, and light just kind of flows anyways and it has energy in it. Charge and the kinetic, and there's sums in energy inside in terms of any of these closed systems like so. These are the kinds of concepts that then are how to relate then what can be discovered in the fields of mathematics in the infinitary with real character, it may be said, as for what results known values, the finite values from concerns of the infinite, unbounded, the actually infinite, if not even just more than effectively, the inverse of a multiplicative annihilator, zero's inverse. These are the kinds of things that help to frame the concepts involved in having a theory that's mathematical with an infinity for all these different matters of scale and how things go together in their continuously rediffer integral systems where a rediffer integral system is kind of like shake it back and forth. It integrates, it differentiates, shake it back and forth. Ta-da. You know, that these kinds of notions in the symplectic manifolds, up after the meromorphic and free analysis, into our quasi-invariant and our continuity laws, with these notions of the continuous domains and what makes the continuous and discrete, what results from the super side of the models when they collapse to the classical and this theory of some potentials in these doubling and halving spaces, most respectively, for those defining regimes, basically, about square integrable spaces, the LP spaces, L spaces, in terms of that being then for the partial, for the harmonic, after the Laplacians, here for this wider side, or Fritz London's, or otherwise, where we'll be looking for the paleoclassical, to find in the paleoclassical where they arrive at the concept of the superclassical. This will be Zeno of Elea. His paradoxes or thought experiments, now they're to be considered, of continuous uniform motion, according to a continuous infinitely divisible quantity called time, that as it's infinitely divided beyond what one can scratch each a piece, arrives at via deductive reason. The evidence for it can arrive phenomenologically because, well, at least you can say it does, according to every meter, measure, and rule, add back up. Then we'll be looking to the paleoclassical, meaning it's like an archaeology dig, the paleo of the classical, to help reflect on what our modern classical is today, to arrive at the concepts what they have for the superclassical and how those relate to this today. So Zeno's thought experiments are really key in that, and the classical exposition of these kinds of notions. Then there's Heraclitus with dual monism, or Zen Buddhism with dual monism. It's one, but it varies. Constancy and consistency and diversity and variety is diverse in various constancy and consistency. That these kinds of notions go into the Fuller dialectic to help make it so that models with values that they see are asymptotic or singular, the flux for the flow, or the how these things build up and pile over to make for the well model, the spike model the other way, that we have a sort of model of the classical vector as a line. It's a ray. It's got one dimension, or it's dimensionless. It's just points. It's a spike. Well, its complement is in a sense kind of the well that it falls into. And so these are the kinds of ideas then how to help relay and detail that this sort of model, the spike in the well, say, or otherwise the needle in the eye of the needle, or something like that, affect to reflect that this notion of the classical and superclassical together as one inner and outer product. Abstractly, the inner and the outer, whereas that anywhere in the mesoscale is just as of finer and finer and fuller and fuller things. This sort juxtaposition, keeping things just as of overall that their balance equals zero, this continuity law is, as of the conservation law, symmetry, invariance, Invariance is, of course, about one of the strongest principles in physics, that which is the rule, the law. This is the rule. And so these are the kinds of ideas that can help to achieve a conception that there always is abstractly this sort notion. And then more specifically a specification of then getting into the objects of geometry, the objects of mathematics, and adding up the parts and then figuring out how those all add up. Sum together, the sum of histories, a theory of sum potentials, SUM, the sum, the sigma potentials. All right, then. Let's see, here's the dictionary of the history and science. So I wonder, looking through this a little bit, I wonder if it'll help. Because now the goal is to kind of figure out that the ancients have already tried to address the notions of the superclassical before. We have atomism. Great. We have Zeno and continuous motion. Fantastic. So there's already atomism in the elementary, and there's the geometric series, that which is infinite. And then from the times of ancient geometry, there are various notions of the methods of exhaustion that only so arrive in the infinite. And then when in the, like from 800 to 1000 AD, or in this time of the world, the most learning was going on in Mesopotamia. It was mostly practical, and not too much is relayed from their researches. But what's before and after that is more so understood and detailed. And so the notions of the infinite series started arriving and arising again after that, after algebra and the symbolic, where there was already a positional place notation, Arabic numerals, Indo-Arabic numerals. It's like, well, what is one of the greatest contributions to mathematics is the Arabic numerals. The 0 through 9. Okay, great. And what's one of the greatest contributions to that is like, well, the Indic numerals were 1 through 9 and the Arabs added 0. Which is required, of course. It's great. So that said, that's classical. It's discrete. But all the way back to the classical, then we have something like the circle's radius is irrational. It's irrational. Must be somehow related by an infinite quantity to any rational thing. So, as a thing. The numerator and denominator would grow until one of them being only of even moduli, the other one would always be of odd moduli. They're still trying to figure out for something like, if you have a square and it's a 1 by 1 square, is there any point in it that's rational distance from all four corners? It's kind of like, well, there's a way to look at it either way, Then the idea is to add that back up and say, when it's this way, it's kind of like when it's on the flux side. The other way, it's kind of like the flow side. Now deal with that and work it out. See? This is where then when you have a hammer, it starts working on everything. So this is the source from about 1980. What I'm just curious to find is anything that kind of helps reflect. So there's microcosm, macrocosm, motion of the solar system. Microcosm, macrocosm. And here that we live in the classical mesoscale. The entelechy, that's like the completion, so that'll be something. Let's see here. the entelechy, the microcosm, macrocosm, nature philosophy. That's physics, you know, vis-a-vis theology. Teleology is the explanations of things. Here we're seeking to grasp at for something like Kant's sublime, for Hegel's teleological, a practical infinity that's actual, whose results are only what so matter for matters of real analytical character. Attraction. See, gravity mostly models attraction, and it's really the key thing is that the tendency or propensity for two things to come together or otherwise fall apart is that it's the opposite way either way, and that it's much simpler to result a formula the one way. The idea is to figure out how it results from the surrounds the other way, because that is more general way. Dualism, that will suffice. Dualism. Actualism, from the earth sciences, microcosm, macrocosm. Theory-laden terms, maybe that'll help first. Theory-laden terms. Let's see here. Theory-laden terms. Mendelism, the study of heredity, stemming from the ideas of Gregor Mendel, whose key assertion was that the reproductive cells of living organisms contain factors transmitting discrete characters. You can turn to Lucretius about 2,000 years before. He pretty much said is like, you know, things are kind of the product of their parents. Mind-body relation. Here, microcosm, macrocosm. Analogies between the nature of man and the form of the cosmos date from antiquity, probably descending from anthropomorphic myths found in many cultures which perceive earth and sky as the father and mother of the creation. In more abstract, rationalized form, this appears in the early natural philosophy of China, India, and Persia. In the Western tradition, both Plato and Aristotle knew it. Plato argued that if the little world of man is physically dependent on the great world, he must also be spiritually dependent on it. If he has a soul, so must the great world. The oldest surviving certain reference to the phrase microcosmos is in Aristotle. So here the microcosm is the subjective man. Vis-a-vis our microcosm today is 50 orders of decimal magnitude, open and closed superstrings, which is twice as far as 25 orders less mass, the hydrogen atom. So microcosm. So in this concept of microcosm today was this day was reflecting to otherwise the heavens and the place in the world of the world and everything on it. Then that was usually over time said to be like it's the center of everything. That's, you know, vis-a-vis what are matters of scale and what are matters of locality and these kinds of things. Numerological correspondences. It's kind of like a metaphor. This comparison of man to the particular parts of the sky attracted the astrologers of late antiquity as a basis for their melothesia, the apportioning of human organs, etc., to particular planets or regions of the zodiac. This is similar with reflexology and lots of different things, which also have sometimes more than the pseudoscientific facts about them. Such connections in the occult sympathies and antipathies, they implied, appealed to monotheists for whom older ideas of the lordship of planets smacked of polytheism. Monotheism is a great thing, and it's sort of self-evident, and it's certainly super scientific. In the Middle Ages, the analogy conveyed something of the godlike nature of the human soul, ruling the microcosm as God ruled the macrocosm. The man is microcosm because his soul can comprehend the great universe. So there's a divide here because as well it comes out as like man cannot know infinity. Well, this is what we need is this one part and the other. Fairly. And there's always, it could be arrived at a very strong justification from a teleological. Monoteleological side is like it's also given. It's a great gift, which fits very well with Platonism and is just so discovered. And then about how to relay that and then how to formalize it, what results, it's limited to the extent that it arrives at a consistency mathematically, rationally. Renaissance philosophers enthusiastically proclaimed the special character of man whose mind can include all of nature. See, this is not dogmatic. Usually it is like, no. Man is limited. It would not be humble. It would smack of hubris. In the usual sense, that's dogma. So here though, there is the Kant's sublime and Hegel's teleological ultimately still does arrive. And it's humble. With the decline of geocentric models of the universe and the appearance of a new physics drawing together man and universe through common laws of motion rather than analogies, the microcosm-macrocosm image faded away. But similar analogies reappeared in 19th century natural philosophy, which compared the evolution of the individual to that of the species, or viewed the universe as a whole as an evolving organism. In early 20th century theories of atomic structure, atoms were often depicted as microcosm, while stars or star systems were macrocosm. So here, from the end of this article, you can kind of see that it's like so. You know that's like so. Mind, see evolutionism, functionalism, materialism, mental atomism, mental disease, mental faculty, metaphysics, mind-body relation, natural philosophy, nervous system, soul. So there's some idea to look at teleology. Oh, and theory. Yeah, there's a theory. Theory specific? What was that? Here's sociobiology. Is an amalgam of many disciplines, including population genetics, ethology, ecology, sociology, psychology, and evolutionary biology. Evolutionism in mind and society. Theory-laden terms, I think it was. Oh, here's statistical mechanics. So the statistical ensemble in statistical mechanics basically defines all what, after it's broken down into, hey, this superclassical model, all we know is it's arriving like random. Just like a law of large numbers would, because the law of large numbers is essentially sampling at random from an infinite space. It's exactly what it is. It's pulling probability theory back together about the discrete and continuous. It's all just mathematically factual about the discrete and continuous. Straight rule. The rule of induction, first formulated and brought into prominence by Reichenbach's theory of probability, 1944, counseling us that in the absence of further information, we should expect the proportion of cases exhibiting some property amongst a population of I elements to approach a limit f sub n plus minus delta, where f sub n is the ratio in the population of n elements so far observed. This is saying that a usual reliable estimator of the uniform is this sample mean. And it reflects among the laws of large numbers, as we've been discussing here and largely discussed last time. So to show that although we cannot be sure that the rule will yield success or prediction, yet is at least as good as any other. Probability theory defines estimators, not predictions. Predictions are only post facto. It is not, the word prediction and statistical hypothesis do not go together. Yet it is still good as any other in that if there is a discoverable limit, it will predict it. It won't differ. So we call those estimators in probability theory today, and they are based upon sample statistics as well. They can be, but they're usually largely properties computed from unknown mathematical distributions. Of course, if the entire population of statistical events is known, then it's no longer random or probabilistic at all. This contention is at the heart of the vindication, practicalist or pragmatic defense of inductive reasoning. Well, inductive reasoning is great until it gets stuck. It's like a person walks in and out of a room. They walk into a room and they walk into a corner. They're walking into a corner. They're walking into a corner. They're walking into a corner. Things change, The main problem is the existence, which Reichenbach recognized, of any number of rival asymptotic rules, counseling us to expect a limiting frequency differing from the straight estimate by any arbitrary but decreasing function of n. To use one of them is to employ a kind of counter-induction, and although this seems unreasonable, this is because we think nature uniform, though the pragmatist has not offered a support for that belief. So you see, they're not being that's non-scientific there. And here are science in its theory, and our probability theory and its statistics and its theory are both the same about falsifiability of the hypothesis. So yeah, that's otherwise it's just reflection on a lot of large numbers. And all the time in the world? No, just all the time that guy had. Theory-laden terms is what we're looking for. Technological determinism. Ugh. There's revivals with the Renaissance. Maybe an example of theory-laden terms deriving their meaning from particular theories and possessing meaning only in their context. And it describes some like psychoanalytic theory, cell, strata, and so on, the melancholic humors, equant, and Ptolemaic astronomy. Language may contain far more theory-laden terms than at first apparent, their nature disguised by the relevant theories being so well entrenched as to be taken for granted. Of course, that's the implicits. The implicits and the explicits, that the implicits go without saying, and furthermore, that they always hold. But if they're not explicit, then it can't be so correlated that patchwork, that piece of the theory, can't be put down only on its own prima facie merits and read off again as a theory, except for those to come together. So theory-laden terms basically is, these days they just call it bias, I suppose, stereotyping and bias, where, of course, bias already has a very specific meaning in statistical probability with regards to reliable estimators and their bias or lack thereof of biased estimators. And with regards to something like the stereotype, whether that's one thing or two. It's a dichotomy. It don't stereotype. Yeah? Or do stereotype. So theory-laden terms just kind of stuck out here. Arguably, even ordinary terms such as perhaps element, star, copper, etc. are really theory-dependent, since although the terms predate our current theories about their nature, their connotations have shifted with theory change and are not the same as in the time of now superseded theories. That's something. Well, what I wanted to look at a little bit here was the teleological telescope, telephone. Teleology, the concept of purpose, telos, and its ramifications figure throughout the history of science as sources of misunderstanding and polarization. Principles abound, and heuristics are commonplace. But and the means and ends are often conflated. And then with regards to the purpose of things, here's among reasons why least action is pretty much the teleological rule in a theory of sigma potentials. And for what great hologram of the holonomic of this so arises that where it all sits. Continuing to read from the entry on teleology, not theology, which is so related. It says of the theos for telos. Teleology. The confusion perhaps originated in Aristotle's doctrine that final causes operate in nature. Because you hear this is first principles and final cause. Whether or not a final cause can be plural or it's really just singular, it's the idea is like it's itself. It is its own final cause. The principles are universal. The cause is personal. This kind of thing. This was wrongly interpreted. I don't agree with this language. To mean that future events influence the world by pulling present events toward them, entelechy. So it references directly to the entelechy, which was mentioned, and maybe this has been looked over a little bit before. But, the entelechy is the completions of the things, their continuous nature. Future events. This is kind of like that. Fate is a sink, and so it's like. It's going that way, vis-a-vis, it's driven that way. There's either tendency or propensity. It's both. Tendency or propensity are the ideas here that we have already to provide a deconstructive account for that. So either way, then we're trying to understand all the surrounds of what is above is what is below. And this fundamental question of metaphysics and all this kind of stuff. Yeah, I know, meters per second. This isn't really getting far from infinity seconds per meter yet, is it? But, is it? To separate the issues, it is important to recognize that ambiguity is inherent in the claim that item X has a purpose. The field may divide it into two broad categories corresponding to Kant's distinction between intrinsic and extrinsic purpose. To have a purpose, in sense one, is to be a purposive agent. In sense two, it is to be useful for some end. Some things in nature have goals, some things have functions, some have both. The classes are also interrelated in various complex ways. So then this is what happens when you get philosophers talking about things like motives and justifications and stuff like that. Is it's like their personal issues get involved with it, and here it's like our inner subjectivity has really got to be an inner objectivity. You know, as it's interrelated in various complex ways. So then the section here describes purposive beings. All agree that human beings act purposefully. We usually read. This sometimes involving a prior conception of the goal. The main problems are to analyze what goal directedness in general consists of. So these attractors or the sinks with regards to the stable, the metastable, the bistable, the locally stable, the globally stable, instable of each of those, the astable. Aristotle and later Leibniz held all individual substances were teleological agents striving for their natural resting places. So today we have like Maupertuis and Euler and talk about least action, and that's the law. None. You know, it's like, what's the law? It's like, it must come down. But that's fair, you know. The main problems. Aristotle and Leibniz held for their natural resting places, Aristotle, or their fullest development for Leibniz. So this is great, because entropy is the idea that everything must fall down. But entropy is also the word, and it's got a lesser known definition, and it is when things, they fill the container and they develop it. So the idea for Aristotle is yes, eventually that rock will be pulverized to dust again. That Leibniz says, yes, eventually out of earth will rise that rock again. While it is so that these things get phrased in for entropy in terms of like information and what is of structure vis-a-vis what is as of the broadest structureless substance, the structure, the underlying structure versus the superstructure. It's great though to have this dualism, right, in the idea of that this is purpose of beings are one way, this both ways, dualistic monism. If such aiming implies the object is alive or has desire, then every individual in nature is alive or has desire. The fundamental criticism of these doctrines, voiced from the Renaissance, is that the alleged striving is empirically undetectable. Well, this is for general justifications, just do it, you know, doesn't matter what you think, you know, this kinds of things. So it's really to be separated what's kind of like the exoteric and the esoteric for individuals and pluralities. And then they may be two different things, whereas each are as well one or the other for themselves. In the 20th century, philosophers attempted to provide objective criteria for purpose of behavior. So here we just, right here so far, right, we just have that Kant is like, you know, and all this theory and stuff, and in the exoteric, it's like, you know, it's coming down kind of a sense, and it's like it's all phenomenological and empirical. The sublime is still more. There is more in the sublime, what it brings. So that we have this from Kant. And Hegel is similarly, he's like, I'm entirely logical, and it's coming on down for science too. So it's all phenomenological also. But there is a teleological still. So these are that through that bottleneck of the canon, which on the one side is deistic as dogmatic, and the other side is scientific as dogmatic, is holistic as dogmatic, holistic monistic, and dual. The goal being to arrive at a dogmatism that's enduring. In the 20th century, philosophers have attempted to provide objective criteria for purpose of behavior. Sophisticated formal characterizations, e.g. plasticity of Braithwaite, the directive correlation of Sommerhoff. Cybernetical accounts were given of the functional organization required of the system, with the notion of negative feedback playing a key role. It's too bad it doesn't understand symbiosis. It's like in the age when there was a coronavirus pandemic for several years. Sometimes people forget is that the bodies had symbiotic coronaviridae doing practical messenger functions in it, since human mammalia were eukaryotes, which is when the mitochondria entered the picture of the cellular organelles. The mitochondria is a different lineage than otherwise what became the prokaryotic cell. Is not. I may be mistaken in that, but the general idea is that the system does not necessarily reject individuals. The cybernetic model that is that way is not necessarily even an operations research thing, which is, on the one hand, there's like, there is one goal, vis-a-vis that it is our goal. So. Yet since the criteria were abstract, a system could be goal-directed without being alive. Such analyses were inspired partly by the invention of guided missiles and other artifacts simulating animals' behavior. They invented a guided missile one day, and it got points for hits. So one day it was like it got a rule it didn't like, so it turned around and hit the shack. Is the story. None of these analyses proved entirely satisfactory, mainly for the logico-semantic reason that the notion of goal is intentional, i.e. what counts as a goal is relative to the agent's point of view. You see, it had bit the hand that fed it, and the goose that laid the golden eggs was gone. Behavior, teleological. So this teleology is about teleology and ontology are these flip sides of coins. So you hear a lot about ontology today. It's like, that's the knowledge base, that's the attributes that are available to evaluation for evaluating rules in the rulio. This is what we make for our expert systems, or anything that so makes for a body of knowledge. In the ontology and the ontological, and the phylogeny and the cladistics the same, and then that the teleology is like, well, see, we just have a theory. Those are real objects of an unknown distribution. What they are, really what they are, abstractly, that is like so, because otherwise, it would not be. So teleology here is kind of like being related to an evolutionary setting. It's not necessarily so attached to it. It's a subjective model of this objective thing here in this article, I would say. So this article would be better called Purpose. And then it goes into the deism and teleological argument. Leave that aside. Super scientific. So, yeah, if there's a takeaway from that, it's that first principles and final cause is a holistic concept. Well, how are we doing today? I hope that things are going well for you and yours, as it may so be that there's a time and a place for everything, and at least one time or place for everything is the common enjoyment of mutual interests and these kinds of things. Here, I'll be studying this some more with regards to meters and second per second per meter. I found a large article on modern logic, which I've been studying for quite some time. So, and then we've discussed that some more here, even just this entry from the old dictionary of the history of science. So I shall so hope you have a great day, and fare thee well.